Hello, good morning. So for today, this will be a video for our solution for this activity. I hope you guys are excited. We're gonna be solving 10 questions, 10 problems. For those who are watching, you can pause the video. Now, can you pause the video and read the instruction first? Let's proceed. Okay, so for our first equation, probably we're gonna be choosing let's start with the shorter one first. Okay, let's try with the bottom right one. 2a minus 4b squared db plus bda. Okay, so our equation is comprising of b and a as the two variables, dependent and independent variables. So I'm gonna switch it up. I'm gonna do a is equal to x, b is equal to y, so that our equation will become x minus 4y squared dy plus y dx. It's much easier to look at it. Okay, first is try to transform it to mdx and dy form. Simplify it first, so it's much easier to look at. 2x minus 8y squared dy, close and open parenthesis, y dx. So right now we don't know what type it is, but I'm seeing a first degree x and a second degree y. So I'm gonna try linear equation, linear in y. This will be our linear form, right? So we divide the equation by dx or dy, dx or dy. We divide the equation by dy and y. So this becomes dx over dy plus 2x divided by y minus 8 y squared divided by y is equal to 0. dx over dy plus 2 over y, x is equal to 8y. Right? Now we can determine our p of y, 2 over y, our q of y, which is 8y. Right? Using our very well-known formula, Yepex, Depex, Quebex, Quebex, whatever, it's in the module or it's in the lesson, right? Or by determining the integrating factor first. Integrating factor, this one, right? The integrating factor is e integral of p of y. That's for linear equation. E to ln y. Apply exponential properties, e ln y squared. Our integrating factor is y squared. Okay, multiply both sides, that will become the differential of y e. Oh, our integrating factor is y x y squared. Y is equal to 8y cubed. Okay. Let's make it let's do it step by step. Right, if you multiply the equation by y squared, the left side will become y squared and dy. The left side will become y squared dx plus x 2y dy is equal to 8y cubed. And the left side will be a product of a product rule. Integrating both sides, we will be getting xy squared plus, oh, that's not plus, that will be equal 8y to the fourth over 4 plus c, cancel, xy squared is equal to 2y to the fourth plus That is already the simplified form, so we'll take it as that. But transform it back to the original variable. So if x is a and y is b, so let's just a b square is equal to 2 b to the fourth plus c. That is our general solution. Okay, so for our second equation, we already solved this, right? Let's do with the ub square. Okay, for the ub square, same strategy applies. I hate to look at uv because sometimes they look the same. So what I'm gonna do is change the u and the v into x and y, so it's much easier to look at. Okay? So let u be my x, let v be my y. Okay, so x y squared plus y minus x dx is equal to negative, I'm gonna distribute the u, right? Negative x squared y dy is okay. So the whole right side is negative. Well, how about let's move the whole right side to the left side, so this becomes positive. Okay. Always simplify your answer so it's much easier to look at. Right? Right? This is obviously not homogeneous because it's not the same degree. Each term is not the same degree. Separable, okay. I'm seeing an x squared and a y squared, so it's not gonna be linear. So for this one, we're gonna be trying exact equation. M with respect to y is equal to the differential with respect to y. Xy squared plus y minus x. Okay. That will become 2xy plus 1, and the differential of n with respect to x, okay, x plus x square y, and poof, what is it gonna be? It's the same. So we can say now that the equation is an exact equation. Exact equation. Right? So if we know that the equation is exact, we can do our theorems, right? So I'm gonna do theorem 3. It's much faster. Or let's do the, let's do the longer version. MDX integral of the right side or left side first. But for exact equation, we're gonna be integrating with only one variable. For the left side, that will become x square y square. See, we're only looking at the x. No, you don't look at your y, you look at your x. Right? X square over 2 plus g of y. Artikulo 1. We add gy at the mdx. Right? Right? So we still have space. Right, so for theorem number 3, we integrate also the right side, the ndy. But for ndy right side, we integrate with respect to or only with y. Square y dy. So that will become xy x square y square over 2 plus f of x, right? So in theorem 3, we identify f of x, which is 0. There's no for f of x, because f of x only contains x. The other equation, the f of x is x squared over 2 negative, while g of y will be 0. Because on the ndy, there's no only y variable term. We have xy variables, xy terms, but there's no only y variable. Right? Then we write the general solution. X square y square over 2 plus yx minus x square over 2 is equal to c. Multiply both sides to 2. X square y square plus 2yx minus x square is equal to c. That's our final answer, general solution. Then again, we transform it back to the original equation. Right? Transforming back to the original equation times x is u, v is y. So u squared v squared plus 2uv minus u squared is equal to c. Right? That's our general equation. And that's our second equation solved. Okay, so we already solved two equations. Let's solve for our third one. How about let's do a trigonometric? I'm seeing a lot of trigonometric terms. How about let's do this one for our trigonometric terms? We're gonna be applying the same strategy all throughout our solution, right? Because I'm much accustomed to using x and y, and we have been solving using x and y. So why not just use let a be my y, b is equal to x. Alright, so this will become y minus x plus xy cotangent x dx plus x dy, right? Right now, I'm seeing linearities, right? So if we divide this equation with dx and x, we will be having dy over dx plus y over x minus x over x plus xy cotangent x divided by x is equal to 0. Right? So for our linear form, we already have dy over dx. Then determine our linear variable y first degree. But there's 2. So we're gonna be separating y plus cotangent x. Right? Then y multiplied to y is equal to 1. Because x divided by x is 1. Okay? So right now, we can see that our p of x is 1 over x plus cotangent x. Our q of x is... Okay. Alright, so let's do another strategy, right? I'm gonna do the ypex dex kebex dex kebex now. Okay, so q of x, e dx 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 plus c. So y e integral of 1 over x plus cotangent x dx is equal to 1 multiplied to e integral of 1 over x cotangent x plus. Remember to double check your values, because sometimes you will forget the plus sign, the multiply sign, or the sign, or the positive or negative. Double check. This is negative x, positive y. Okay. So I'm gonna work on the integrating factor first. So 1 of x plus cotangent x dx, right? And 1 over x will become ln x. Ln x. But what's the integral of cotangent x? So that's cosine x over sine x dx, right? If we let u is equal to sine x, then the differential of u is cosine x. And that will become ln sine x. Okay, and simplifying it further, it will become e ln x multiplied to e ln sine x, or x sine x. This is now our integrating factor. Why? X sine x is equal to integral of x sine x dx plus c. This is an example of integration by parts. Let u is equal to x, du is equal to dx, dw is equal to sine x dx, w is equal to negative cosine x. Alright, so y x sine x is equal to negative x cosine x minus integral of negative cosine x dx plus c. Y x sine x is equal to we could take our time, right? Let's not rush our solution, but that will become positive sine x plus c. Right? Move the negative one to the opposite side. That will become x y sine x plus cosine x is equal to sine x plus c. And that is now our general solution. Right? Do we have an IVP? No. So that is now our general solution. Okay, we have solved 3 problems or equation already. How about let's do another trigonometric. But let's do this one because I don't want to let x and y or b is x, or I don't want another variable anymore. Now, how about let's do this. Tangent square y dy minus 3 cosine square x dx is equal to sine cube x dx minus 3 1 minus sine square x dx. Okay. First, how about let's transform them into mdx and ndy first. Okay, so I'm seeing a lot of dx, so we're gonna be transposing or moving all the dx to the left side. So that becomes tangent y dy minus 3 cosine square x negative minus sine cube x negative positive 3 1 minus sine square x. Alright, then that will become, or that will be multiplied to dx. Right? So I'm seeing a lot of square using I see something. Notice this is negative 3 cosine square x. Okay, and trigonometric identities. This is sine square x plus cosine square x is equal to, and cosine square x is equal to 1 minus sine square x. Meaning this is 3 cosine square x. And positive 3 and negative 3 added together, well, positive 3, negative 3, that's 0. Alright, that's 0. Okay, so our equation will be tangent square y dy minus sine cube x dx is equal to 0. Okay, and integrating tangent square y, integrating, but there's no direct integration of this two trigonometric functions, so we're gonna be applying some identities. First off, sine square y over cosine square y, or tangent y, right? Then we're gonna be separating the sine square x and the sine x for the dx, right? Oh, by the way, this is now a separable equation. Separable equation, your m of x is negative sine cube x, and your n of y is tangent square y, right? Applying some trigonometric identities, sine square y is equal to 1 minus cosine square y over cosine square y dy, and that will become 1 over cosine square y minus 1 dy, right? And that is integral of secant square y minus 1 dy. Okay? For the opposite side, or the x side, that will become 1 minus cosine square x sine x, okay, dx, okay, minus sine x minus cosine square x sine x dx. Now, this is a lot more easier to integrate, right? For our left side, secant square x has a direct integration, right? Our leftmost part, we have a direct integration for that. That is tangent y. Direct integration of negative 1, that is negative y. Direct integration of sine x is positive cosine x. Direct integration of that is no, there's no direct integration, but if we let u is equal to cosine x, the differential of cosine x is negative, du is equal to negative sine x dx. So that's gonna become u squared positive u squared du. Okay, and that's gonna become plus cosine x plus cosine cube x over 3 is equal to c. Multiplying both sides to 3, and we're gonna have 3 tangent y minus y plus 3 cosine x plus cosine cube x is equal to c. That is now our general solution. Okay, double check if we have an IDP. There's no IDP. That is now our general solution for our differential equation. Okay, so we already solved 4 problems. How about let's do the first one? Let's do the first one. It's short, x and y, and I'm seeing a trigonometric function but with a fraction inside. So experience-wise, this is an example of or probably this is an example of an homogeneous equation. Okay, we substitute test. Let's do a test first, right? So let x is equal to lambda x, y is equal to lambda y. Even though the homogeneous equation will have lambda inside the trigonometric function, but because it's a fraction inside, okay, the lambda will be cancelled out, and we can still separate a lambda. We can still separate a lambda from the equation itself. Okay, there we go. Are you guys seeing this? So we can now say that the equation is therefore the equation is homogeneous of degree 1. Right? So this is now a homogeneous equation. Let y is equal to vx, dy is equal to v dx plus x dv. So in this case, this will become x cosecant. It's still gonna be cosecant. Right? Cosecant v x over x. Cancel x. right, minus vx dx plus x v dx plus x dv is equal to 0. X cosecant v minus vx dx plus x v dx. Once we substitute our y equals bx, our variable v, it should be separable. So transpose that or combine like terms. Oh, this is negative, this is positive. So we will be canceling those two terms. It's the same, negative bx, positive bx, x cosecant v dx plus x squared dv. Divide both sides by homogeneous equation. Our derivative of x has a cosecant v. Our derivative of v has an x squared. So we divide those. We combine like variables to its own derivative. So this becomes x dx over x squared plus sine v dv. Remember, 1 over cosecant v, right? And cosecant v is 1 over sine v. So 1 over cosecant v is the same as 1 over sine v. Okay? Equals 0. Integrating both sides, cancel. This will become ln x plus negative cosine v is equal to c. Substitute back. V is equal to y over x. So ln x minus cosine y over x is equal to c. That is now our general solution. Okay, double check. Is there an IDP? Okay, so that is now our general solution. Okay, so we're now on we already solved 5 problems. We're gonna be solving our 6th one. How about let's choose this one? First, write it down. So this one has, we have, I'm seeing, y dx is equal to, I'm gonna distribute the x dy first. X dy, or, okay. So notice this is 1 minus cosine square y over x, and that's equal to the same equation, right? X dy. Okay, let's transform it to mdx and dy form. Okay, so this becomes x plus y sine square y over x dx as equal to sine square y over x negative x dy. Okay, it's probably homogeneous equation. Whenever I see y over x in a trigonometric function, that's always a homogeneous equation. Okay, so that's gonna be lambda x plus lambda y sine square lambda y over lambda x. Okay. No matter what type it is, just follow the instruction, or just follow the step-by-step how to solve our differential equation. Okay, substituting, cancel the lambda on our trigonometric function. Notice that we have lambda on each terms, so that's gonna become lambda x plus y sine square y over x dx minus sine square y over x dy. We can now say that this is the equation is homogeneous of degree 1. For the solving, we proceed as follows. Let y is equal to dx, the same as the other one. Okay. Then dy is equal to v dx plus x dv, where v is a variable. So x plus y, bx sine square dx over x, cancel x, right? dx minus sine square dx over x, cancel x, right? X dy equal to 0. Oh, dy is now v dx and x dv. v dx plus x dv. Okay, once we substitute our y equals vx, our equation now is separable. Simplify further. Right? dx sine square v dx minus sine square v x. I'm gonna put x on the left side so we don't confuse it. v dx, right? v dx plus negative sine square v x square dv is equal to 0. Okay? Combine like terms. Oh, this is v dx negative, right? This is positive. It's the same, but only positive and negative, so it's gonna get cancelled out. And this, our equation will be x dx minus x squared sine squared v dv. Divide both sides by x squared. X dx over x squared minus sine squared v is equal to 0. Okay? Cancel the square, dx over x, and in order to integrate sine square v, we apply half angle, double angle, whatever. No, it's half angle. I'm just kidding. I'm sorry. Right? So half angle, if cosine square theta, right, plus sine square theta, right, is equal to 1. Cosine 2 theta is equal to cosine square theta minus sine square theta. Right? Sine 2 theta is equal to sin cos cosine, right? Sin cos. So if we have sine square theta, which is this one, right? Which is this one, right? So this becomes cosine 2 theta is equal to cosine square theta minus sine square theta. Applying 1 minus sine square theta minus sine square theta, right? Theta, 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 theta. Transposing the theta. Okay, I'm sorry. Let's get serious. Transposing the negative 2 sine theta to the opposite side, 1 minus cosine 2 theta divided by 2. So our sine square is equal to 1 half minus 1 half cosine 8. Or cosine 2v dv. We can now integrate. So this can become ln x minus 1 half v minus 1 half. The integral of cosine 2v is sine 2v divided by 2v is equal to c. Okay. Okay, substituting back, if y is equal to vx, v is equal to y over x, then ln x minus 1 half y over x minus 1 over 4 sine 2 y over x. Multiply both sides by 4, so this becomes 4 ln x minus 2y minus sine 2y x is equal to c. This is now our general solution. Okay, that's a general solution. Is there an IBP? Not yet. We're still not solving IBP problems. Okay, so that's it. Okay, so we're getting there. We're halfway there. How many problems still left? 1, 2, 3, 4. 4 problems. 4 more problems. We already solved 6. If that's 10 problem, we already solved 10%. And if you guys are catching up, or you guys are following or understanding how we solve each problem, good for you, guys. All right. Anyways, how about let's solve for an IVP. Let's solve this one. Cosine x minus sine x minus y dy is equal to y sine x cosine x. Okay. Always simplify your problem, or do the mdx and dy. Okay. It's much easier to solve for problems if it's in the general form. So I'm gonna transpose dy to the opposite side, so this becomes y sine x plus cosine x. Okay, that's a pretty big S, right? Negative cosine x, positive sine x, positive y dy. Right? Because I transpose it to the opposite side. I move it to the opposite side. Okay. This cannot be homogeneous. There's trigonometric functions. Separable? No. We cannot separate x and y. Linear? No. There are x and y on. Oh, there is an. Is that y dx? Y dy. So it cannot be linear in x because x is in a trigonometric function. Then it cannot be linear in y because y is already in dy. So it cannot be. Let's do exact. Right? So for the dx side, or the left side, right, dx, differential, right? Differential with respect to y. This will become sine x cosine x, positive. Because, there's no y. We only have one variable y. And the differential of y here is 1. For the dy, or the right side, we're going to differentiate with respect to x. Cosine x plus sine x plus y. It's gonna become sine x positive and cosine x positive plus 0, because y is a constant. Therefore, the equation is exact. And if it's an exact equation, in the left side, y sine x plus y cosine x. I distributed y already to our two terms, sine x and cosine x dx. And that will become, the integral of sine x will become negative y cosine x. And the integral of cosine x is y sine x plus g of y. Theorem 1. We're going to be using Theorem 1. D dx. For Theorem 1, derivative of y, right, of the integral of m dx. So that will become the derivative of y, negative y cosine x plus y sine x plus g of y. Because the two trigonometric functions have y, that will become negative cosine x plus sine x. The derivative of y is 1. So plus g prime 1. And that is equal to n. And n is equal to negative cosine x plus sine x plus y. Is that plus y? Oh, it's negative y. Negative cosine x plus sine x plus, no, it's plus 1. It's positive 1. Cancel. G prime y is equal to y. G of y, when you integrate g prime y, that will become y squared over. Okay? Getting our general solution, your general solution is negative y cosine x plus y sine x plus y squared over 2 is equal to, multiply both sides to 2, getting y sine x, 2 sine x, right? 2 sine x minus 2 cosine x. I'm just gonna do this. 2y sine x plus minus cosine x, right, plus y square is equal to, that is now our general solution. Okay, is there an IBP given? What did we solve? This one, x is equal to pi, x is equal to pi, and y is equal to 2. Substituting 2, right, 2 times 2 sine pi minus 2 times 2 cosine pi plus 2 square is equal to c. C is equal to 4. Cosine pi is negative, positive. Well, negative 4 multiplied to negative 1. 2 times 2 is 4 times 0. So that's going to become 4 plus 4 is equal to C. C is equal to 8. Okay, okay. I'm going to be double checking my answers. It seems correct. Okay, so our particular solution now is, our particular solution will now be 2y sine x minus cosine x plus y square is equal to 8. This is now our final answer. Okay, so far so good. How many did we solve? 7 already. There's 3 more to go. That's very good. Very good for us, right? How many minutes have passed? I don't know. Let's look at the time later once we finish our all the problems or the equations we need to solve. So I'm gonna do the u1 first, right? U square plus 1. A minus 1 du plus eu square v square dv is equal to u square v square dv. You know, just for a is a parameter, u is equal to 1, v is equal to 3. You know, just for teaching purposes, we're not gonna be substituting u for x and y for b, right? So just to show that you don't need to use x and y. But I think I'm gonna have a problem later, right? So u square I just want to persevere with it, du. I'm gonna transpose v to the opposite side, so this becomes a u square v square minus u square v square dv. Okay, so this is du, this is dv. Okay, u square plus 1, a minus 1, du. Is this separable? A minus 1, u square v square dv. Divide both sides by a minus 1. So we can cancel out the a minus 1. This becomes u square plus 1 du is equal to u square v square. This is plastic. This is separable equation. Separable, right? Divide both sides by u, so this becomes u square divided by u plus 1 divided by u du plus v square dv. Very well, it looks hard at first because there's a lot of u, but it's manageable, right? Very short, and when sometimes when your equation is too short, you just need to lengthen your solution, so you have a solution. Because if your equation is too short, you won't have a solution. There won't be anything to check. Integrating both sides, because for separable equation, the m of u is u plus 1 over u. The n of v is v squared. Now integrating both sides, we are gonna be having u square over 2, right? Plus ln u plus v cube over 3 is equal to c. Multiply both sides by 6. 3u square plus 6 ln u plus 2v cube is equal to c. Okay, what else? What else? What else can we do? That's our general solution, right? Is there an IVP? Yes, there is. U is equal to 1, V is equal to 3. 3, 1 plus 6 ln. Wait, is that gonna be... Wait. Oh, okay, always double check. We divide both sides by u square. This should be u square. Okay? Not so fast, right? Sometimes when you're doing an equation too fast, you're gonna get wrong. Because it's sometimes you think it's easier, right? Oh, it's wrong, right? See? I make mistakes when I'm doing things so fast. So your m of u is 1 plus 1 over u squared, and your n of v is v squared. Okay? So this will integrating our equation. That will become u plus u negative 1 divided by negative 1 plus v cube over 3 is equal to... Simplify it first. We multiply by 3u. That will become 3u squared minus 3 plus uv cube is equal to cu. Okay? And this is now our general solution. Then again, we have an IDP, right? Yes, we have an IDP. U is equal to 1, V is equal to 3. U is equal to 1, V is equal to 3. So 3 times 1 squared minus 3 plus 1. 3 cubed is equal to c times 1. 3 minus 3 plus 27 is equal to c. C is equal to 27. It's not the particular solution. No, you just substitute. 3u squared minus 3 plus uv cubed is equal to 27u. That is now our particular. That is the answer to our 8th problem. Okay, so we're gonna be solving our 9th equation. Almost there, last 2. I hope you guys are excited to finish this video. Anyways, let's proceed to our second to the last problem. Okay, let's just do what's next. This one. Yeah, this one. A squared minus 1 ta minus t. Okay, so first off, let's just substitute x with b. Y is equal to a. So 2x dy is equal to y squared minus 1 dx dy minus dx. Okay, so 2x dy distributing y squared minus 1 dy minus y squared minus 1 dx is, transpose to the opposite side. 0 is equal to y squared minus 1 minus 2x, right? dy minus y squared minus 1 x, right? That's not homogeneous. Why? Because there's a y squared. It can be linear. Your x is first degree. Is it exact? This is your x, right? So y. This is your mdx. So d over dy is negative y squared minus 1. So that's gonna become negative 2y, right? Then for nx, d over dx, that's y squared minus 1 minus 2x. And that's negative 2. Alright, so it cannot be It cannot be exact. Let's do linear. I'm saying linear in y because I linear in x because your x is first degree. See that? X is first degree. So let's divide both sides by dy and negative y square minus 1. Okay, so this becomes dx over dy, right, plus y square minus 1 divided by y square minus 1 negative minus 2 over y square minus 1 negative multiplied to x is equal to 0. This will become positive and that will be cancelled. That will become 1 transposed to the opposite side. Dx over dy will become 2 over y square minus 1 multiplied to x is equal to your p of y is 2 over y square minus 1. Q of y is what? Okay. Using our famous formula, famous last words, famous formula. Depex, depex, kebex, dex, whatever. Right? 2y square minus 1. Actually, it's not Depex. It's our linear variable is x. So x e integral of 2 over y square minus 1 dy is equal to the q of y, which is 1, e integral 2y square minus 1 d of y is equal to plus c. Okay? First off, that's not directly integrable, right? This one is not directly integrable, your p of y. Then again, let's apply partial fraction, right? Y plus 1 and y minus 1. Right? Applying partial fraction, 2 is equal to ay minus 1 plus b, y plus 1. Okay? 2 is equal to ay minus a plus by plus b. A plus b are only the y constants, y variable, right? Is equal to 0, a is equal to negative b, then 2 is equal to negative a plus b. If a is negative b, so 2 is equal to b plus b, then b is equal to 1, a is equal to negative 1. Right? Meaning, this partial fraction is now negative 1 over y plus 1 plus positive 1 over y minus 1. Meaning, e integral of 1 over y plus 1 negative plus 1 over y minus 1 positive. And the integral is e ln y plus 1 negative 1 plus ln y minus 1. And that's positive. Meaning our integrating factor is e ln y minus 1 divided by y plus 1. Okay? Meaning y minus 1 over y plus 1. Okay? That's our integrating factor. Further substituting, x y minus 1 divided by y plus 1 is equal to the integral of y minus 1 y plus 1 dy is a plus c, right? This one, right? Is there a direct substitution for that? Probably. How about let's use, I'm gonna write this. Y plus 1 is equal to the y minus 1 over. Okay, we can just use let u is equal to y plus 1. Du minus 1 is equal to y, right? Du is equal to dy. So that's gonna become u minus 2 over u du plus c. integrating u minus 2 over u, or 1, right? 1 minus 2 over u t plus c. Integrating u minus 2 ln u plus c. X, y minus 1 over y plus 1. I simplify further. X, y minus 1 is equal to y plus 1. Y plus 1 minus 2 ln y plus 1 plus c. Multiply both sides by y plus 1. X, y minus 1 is equal to y plus 1 squared minus 2 y plus 1 ln y plus 1 plus c y plus 1. Ooh, there's a lot of y plus 1 there. But is there like any common term? I'm not seeing any. Okay, so we're gonna wait. Is there an IDP? There's no IDP, so this is now the final answer, or this is now the general solution to our differential equation. Okay, so this will be our last problem. Let's continue, right? So 3 plus y plus y squared sine 2x. Oh, it's not 2x, that's square x, right? So we're gonna be having our trigonometric function. Let's see if we're gonna be using a trigonometric identity. As I'm seeing, probably we're gonna be using, or I'm guessing this will be an exact equation. Okay. Right, so let's do an exact. And with respect to y, d over dy, 3 plus y squared sine square x, that's gonna become 0, plus, because the differential of 3 is 0, the differential of y is 1, plus 2y sine square x. For the right side, right, that's gonna become d over dx, x plus 2xy minus y sine x. We're gonna be focusing on the x side, so on the x only. So that's gonna become 1 plus 2y, right, minus 2 cosine x, right, 2 cosine x. Right, because this is different, right? Okay, difference. Because those two are different. I'm gonna try to manipulate this. This sine square 2x, sine square x is equal to 1 half minus 1 half cosine 2x. So that's 1 plus 2 y 2 y 1 half minus 1 half cosine x. That's become 1 plus y minus cosine x. Ooh, that's not exact. Not exact, right? Did we get something wrong? Y sine 2x, 2xy. I think we did it correctly. Anyways, it's not separable, it's not linear. How about let's try our last type, homogeneous. But then again, inspection, it's not gonna be good. Okay. Okay. It's not gonna be good. Okay, so let x is equal to lambda x. Y is equal to lambda y. We're gonna be, even though we know it's not gonna be homogeneous, we're gonna do it because it's the proper procedure. And in order to officially test whether it's homogeneous or not, x plus lambda x plus 2 lambda y plus lambda x minus lambda y sine 2 lambda x. So notice that our lambda cannot be separated initially because there's 3. So therefore, the equation is not homogeneous. Okay? So, in our instruction, determine whether the following differential is, so it's not separable, it's not homogeneous, it's not linear, it's not exact. Okay? There we go. If it's not those 4, we cannot solve for the general solution. We cannot solve for the particular solution. Right? And right now, we cannot solve it. Okay? Then again, the instruction says test for it. So, we need to do as follows. We need to test for it as follows. Okay. Thank you so much. That's our last problem. Thank you.